Hello guys, and welcome back to the next video, circles and lengths of segments. This is section 10.7, not 9.7, it is section 10.7. And in this PowerPoint, we're going to be taking a small turn from what we've been doing so far, and we are going to talk about the lengths of the segments. Okay? Now, beforehand, we've been talking about the angle measures and the arc measures, and we've spared a few moments for arc lengths. Now we're going to dive in deep and go into the lengths of the segments. Okay? Now, you may or may not notice some familiar pictures, so please make sure that you are paying attention to what the question is asking you for, whether it's asking for the angle measures or the segment lengths. Now, there are three main theorems in this section. First one you have is a segment of chords. Okay? Now, when you have a segment of chords, you are going to multiply the pieces together and set them equal to each other. So, in other words, this is A and right. If this is A, and this is B, and this is C, and then D, we know that A times B is equal to C times D. Okay? So you're going to multiply the pieces together and set them equal to each other. Now, the next one is the segments of secants. Okay, so the first one was when you had two chords. The second one is when you have two secants. Now, if you'll notice, there's a similarity where you're multiplying the pieces together and set them equal to each other. However, let's look a little deeper. AC is the whole segment. I'm going to call it that. It's the whole segment. And then AB is the outside piece. Okay, it's this outside piece right here. And so unlike the first one, you're not doing piece times piece. You're doing whole times the outside piece. Okay, so here we go. We have the whole segment times the outside piece is equal to the whole segment times the outside piece. Finally, we have the segment of secants and tangents. So this is where you have a secant and a tangent, as the name suggests. Now, the nice thing about this one is it's very, very similar to the secant of secants, or the segment of secants. Okay? But instead of there being a whole times an outside piece, you just have this tangent line. So instead of multiplying two things together, you just have the tangent line squared. And then you have your regular rules from the secants on the other one. So you have the whole piece, the whole segment, times the outside piece. So you have the whole segment times the outside piece. All right? And these are the three theorems that we'll be using in this video especially, but then as we go and we solve problems. So make sure you have it straight in your head. Have this chart somewhere in your notes. That way you can easily identify the pictures with the problems and the equations. That being said, let's do some problems. Now, what we're going to do on each of these is we're going to identify the correct equation that fits the picture, and then we're going to solve for the variable. Okay, so this first one, the video is going to pause. Please pick the correct equation, and when it plays again, we'll solve. Okay, so this is segments of chords, and this was the A times B is equal to C times D one from the last slide. And I have that equation plus the proper names of the segments right here, just to remind you that A, B, and C are just variables, okay? What you're really doing is you're multiplying the segment lengths together. So this segment length times this segment length. Okay, this segment length times this one. Okay? And then we're going to solve for it. So I've got 4 times 4 is equal to 8 times x. 16 is equal to 8 times x. And we have that 2 is equal to x. All right, go to the next one. The video is going to pause. Please select the correct equation. Okay, this is another segment of secants, and again, segment of chords. My apologies, segment of chords. And again, I used the proper letters. I used the proper name of the segment pieces so that you can see which one I'm using. Okay, so this first one, ZP, is going to be x plus 3. And then PX is going to be x plus 4. Then I have WP, which is just x. And then I have PY, which is x plus 9. All right, now I have a binomial times a binomial, which means I need to FOIL. So I'm going to multiply my x's together. And then right there. And then distribute the x on the other side as well. Now, if we're lucky, the x squares will cancel out, and thus saving us the trouble of factoring. And hey, we are lucky. The x squares do cancel out. But still, always be prepared for the possibility that you could factor. All right, so then I'm going to combine like terms, and I've got 7x plus 12 is equal to 9x. And x is equal to 6. All right, to go ahead and pick out the proper equation for number 3, and then when it plays again, we'll solve it. All right, so this one is a tangent and a secant, so I used that equation. Now, we got to be careful on this one. Let's mark it properly. So this piece right here is the tangent. This whole big side, GJ, is our whole piece. And then this is our outside piece, HJ right there. Okay, so when I do this, I have 6 squared is equal to the whole piece, which is 4 plus x, times the outside piece of 4. And now I can combine like terms and distribute. So 6 squared is 36. Minus 16 is 20 is equal to 4x. X is equal to 5. Last one, please pick the correct equation and then we'll solve. All right, this one is a secant of secants. If you look very carefully, you can see that AE is not a tangent line. And so we're going to be very careful. Actually, I'll use the correct names. The whole will be AD times AB is equal to AE times AC. And so we're going to plug in directly into that equation. So AD is 5 plus x. AB is 5. AE is 12. And AC is 7.5. Now I'm going to distribute and combine like terms. So I have 25 plus 5x is equal to, that becomes 90. 90 minus 25 is 65. And then divide by 5, x is equal to 13. And there we have it. Those are our first 4 problems. Please make sure you have these in your notes so that you can refer back to it later. All right, yay, more problems. So we've got 5 problems left in the video, 3 on this slide, 2 on the next one. What I want you to do is solve for the missing variable, and then you're going to plug your answer into the question when the video pauses. Good luck. Okay, so here's the answer for the first one. Now on this one, it was a segment of secants. So you have to do the whole times the outside piece, whole times the outside piece. And in this one, we did not get lucky because if you used the correct pieces, you ended up getting an equation that you had to factor. Okay, so I'm going to start explaining the problem from this step. I assume you got to here with no problems. Now remember, when you factor, you have to have all your terms on the same side of the equal sign. And I pulled C off to the side over here. That way I could figure out what two factors of negative 36 multiply to negative 36 and add to a positive 9. Okay, so two numbers that multiply to C add to B. In this case, it ended up being negative 3 and 12. So I plugged those into our parentheses and set it equal to 0. Then you take each variable piece and bring it out and set each of those pieces equal to 0 and solve for x. Now in this case, I had a negative answer and a positive answer. Since RT can't be a negative 12, you just can't have a negative side length, the only possible answer is 3. All right, try out 3B. When the video plays, we'll go over it. And here's the answer to 3B. The only thing I'm going to say on this one is don't be afraid of fractions. All right, even if they are improper and they don't look like we normally have them, they are still valid answers. Be nice to them. All right, try out the next problem. When the video plays again, you will see the answer. All right, now this one was a little bit trickier. So when you put your pieces together, so first off it was tangent and secant, segment of secants. And then when you multiplied your pieces together, you probably got to here when you realized that that x squared wasn't going away. All right, now with this problem, the extra step you had to do was pull out a GCF. So all three of these terms, we're going to back up a step to this step right here. All three of these terms, 2x squared, negative 14, and negative 36, they're all divisible by 2. And so when we go to the next step, I can pull out that GCF and leave it up front. Okay? And then I have x squared minus 7x minus 18, and I can factor that equation. Okay? So I pull 18 off the side, and my question is, what two numbers multiply together to give me negative 18 and add together to give me negative 7? And the answer is positive 2 and negative 9. Okay, so that's what goes in your parentheses. And then you pull each piece out of the parentheses and solve for x. And you get x is equal to a negative 2 and x is equal to 9. Again, because the segment can't be a negative length, you have to the only answer you are allowed to have is x is equal to 9. All right, now this problem especially might have caused you a little bit of problems. So if you got it wrong, definitely look at my answer, but also put it away and try to resolve the problem on your own. All right, that way you can be sure that you can start it, do it, and then finish it all on your own. All right, now these are the last two problems in the PowerPoint. If you want, you can pause the video now and then compare your answers to mine. Otherwise, I'm going to do them with you because they do have a few more steps than the other problems. All right, so this first one, number 18. The extra steps on this one is that you have two circles. Okay, in the other problems, we didn't have two circles. We only had the one. And so now, for each circle, we're going to have a different set of equations. Okay, so I'm going to start with the one that gives me the most information, and that's actually the small circle. Okay, so my first question is, what set of equations do I use for the small circle? And I see that this segment right here this segment right here is a secant, and this one right here is a tangent. Okay, so I'm going to call this tangent the shared piece y, and I'm going to do the tangent squared is equal to the whole times the outside piece. Okay, and now, so I'm going to call this one circle A and this one circle B. So let's look at circle B just as we get a feel for the whole problem. And as I look at circle B, I see that it is also a tangent and a secant. And so it also follows this pattern. Well, I think I said it earlier, but they both share this y side. Since they both share the same side, they're both going to be equal to the same tangent squared. I should eventually be able to just put them together and set them equal to each other. Now, if that went over your head, it's okay. I'm going to do it one piece at a time, and then I'll tell you at the end what I mean by this. So first off, circle A. So I've got y is my tangent, so y squared is equal to, the whole thing is 14 times 7. So 14 times 7 is 98, so I have y squared is equal to 98. Okay, well, now I'm going to pause for a second and look at my circle B over there. So I have to have the tangent squared is equal to the whole piece times the outside piece. Well, t squared, the tangent, t squared is 98. Okay, I just solved for that right here. I haven't figured out what y is, but I don't necessarily need y. All I need is t squared. So now I'm going to take t squared, or 98, and plug it in over here. So I have 98 is equal to 5 plus x times 5, and I can keep solving. So 98 is equal to 25 plus 5x, minus 25 to both sides. And again, don't be scared of fractions. They are numbers too. Now, this last problem has a couple of steps. So, right away, I can see that I have a chord and a chord. Okay, so I can do the chord times a chord. So, the A times B is equal to C times D. But then I also have this tangent line right here. In which case, the only option I have that includes a tangent is the tangent and a secant, which means that this is my secant line. Okay? So I have the chord and a chord, and then I have the tangent and a secant. So I'm going to look at the two equations and figure out which one do I have the most information for. I'm going to solve that one first. So when I'm looking at this, the chord and a chord, well, I have an A variable, or a B variable, and an A variable. So that would be 6 times A is equal to 8 times B. Well, I can't solve that equation just yet because, well, I don't have enough information. So let's go to the tangent. Tangent would be 10 squared is equal to, now you got to be careful because the green line is your whole piece. So this is going to be 4 plus A plus 6 times the outside piece of 4. Now this one looks much better. I only have one variable, A, so I'm going to solve this one. So I've got 100 is equal to 10 plus A times 4. Be careful when you distribute. Okay. And we're cruising right along with the basic algebra. A is equal to 15. All right. That is awesome Now I can plug this in to my other equation and solve for b. So I've got 6 times 15 is equal to 8b. Well, I've got 90 right here is equal to 8b divided by 8. Again, don't be afraid of fractions. They are not your enemy. All right, if I divide both of these by 2, I get 45 over 4 is equal to b. And that is as far as you can take it. This is your final answer for b. All right, well, that is it for this PowerPoint. If you have any questions, please make sure you write them down, and I will see you next time.